This is chapter 4, factoring with difference of two squares. If you watch the trinomial video, this is going to start off very similar. I apologize for repeating myself, but it might come in handy. So factoring is understood to be something times something. So we're going to go and turn it around, go the opposite way first. Here's my something times my something, and that's just a FOIL problem. So if I did the first one times the first one, I would get 4n squared. Now, if I multiply the outside guy, I'm going to write it up here above, I get a negative 18n. And if I multiply the inside two guys, I get a positive 18n. And what would happen to those two guys? They would cancel and it would go away. So I'm down to last one times last one, which would be negative 81. Okay, so here's the point. On a trinomial video, we would start off with a trinomial and it would factor into two parentheses. But this time, I ended up with a binomial. So that's, as far as recognition goes, that's going to tell you you're doing a difference of two squares. So I've got a binomial, two things, and I've got perfect squares. In other words, a 4 is 2 times 2, and an 81 is 9 times 9, and the n squared, for that matter, is n times n. So they're all perfect squares. So down here, underneath, I got an x squared minus 49. Well, it's a binomial with a subtract in the middle. So, and that's what difference means, subtract. So difference of two squares. And are they squares? Well, yeah, because 49 is 7 times 7, and x squared is x times x. So just like the previous video, we undo it. So I'm going to start here with the thing that's first in my problem, which is the x squared. And if I undo it into something times something, well, x times x gives me x squared. And I drop down to the 49, and I say again, something times something, that's 49. So I undo it and make it 7 times 7. But again, these are squares, so it makes it a little bit easier. You're not debating whether it's, 2 times 8 or 4 times 4 or 1 times 16. It's like literally a number times itself all the time. So the other thing that we need to consider is the sign. And it's always going to be a minus in the middle for this particular kind of problem. And what's the only way you can get a negative answer? Well, it's not a positive times a positive, obviously. It's not a negative times a negative, because that would give you a positive 49. So the only way that you can get a difference of two squares is if the answer has one negative and one positive. So there we go. Now again, it's recognition. There's all kinds of different kinds of factoring. So this doesn't apply to every single kind of factoring, but it does for these. So if you look at number 1, I see a binomial with a minus in the middle, and I see squares. If you look at number 2, I see a binomial with a minus in the middle, and they're squares. And if you see number 3, even though there's a fraction, it's still binomial, and it's still a minus in the middle. So for these, and again, just this kind, the only way I can get a negative answer is to have a positive times a negative. The only way I can get a negative answer is to have a positive times a negative. Now, it doesn't matter which one you write first. You can write the minus first and plus second. I just tend to write the positives first. And then this is the easiest of all the kinds of factoring you're going to do. So it has to be the same something. Well, how do I get m squared? It'd have to be an m times an m. And again, since they're perfect squares, we're not debating any way to get 121 besides a number times itself. Number times itself that gives you 121 is 11. 1 minus 1 plus, and we are done. So number 2, a little bit more to it. There is a 25 with the j squared. But if I went 5j times 5j, that not only covers the 25, but it covers the j squared as well. And what number times itself is 9? 3 and 3. Perfect squares, 1 minus 1 plus. So a little more complicated, but to get c to the 6th, okay, now, c to the 4th and c to the 2nd would work, c to the 5th and c to the 1st, but you have to use the same thing because they're perfect squares. So the only way I can split up 6 c's is to use 3 of them and 3 of them. Okay, remember the rule for multiply. If I multiply those back together, c to the 3rd times c to the 3rd, add the exponents, I would get c to the 6th. Okay, now the fraction, don't let it scare you. I want to make a fraction bar. Fractions like doing 2 separate problems. Rather than tackle the whole thing at once, think of top, think of bottom. Just look at the top. I got a top of 25. Well, what times what is 25? 5 times 5. Now worry about the bottom. What times what is 64? 8 times 8. So guess what times what is 25 64s? 5 eighths and 5 eighths. So again, to recap, this is the easiest kind. You're going to be using the same numbers, 5 eighths and 5 eighths, the same variables, c to the third and c to the third, 1 plus, 1 minus every time. All right, hope that made sense. Thanks for watching.